Hey everyone, welcome to hok'stutoring. I hope you're having a great day because today we are doing question 21 from your vector proof chapter. So that is chapter 2F. Right, so vector proof is one of the most hated topic for many special students, but not you guys. After watching this video, hopefully it'll help solve some of your vector proof fears. Right, so question 21, this is the last question of this chapter. It's also one of the hardest question, if not the hardest question in the chapter, outside of chapter review. So let's get into it. Question 21. In the figure right here, the circle has center O and radius of R. Okay, so the length from O to any point in the circle is R. The circle is inscribed in a square A, B, C, and D, and P is any point on the circle. So it's pretty much been labeled for us already in this diagram. Part A, show that vector AP dot product vector. Part A, show that vector AP dot product vector AP equals to 3R squared minus 2 times vector OP dot product vector OA. And then we'll do part B afterwards. So let's get into part A first. So whenever you encounter a show question, you have to work on only one side. So either the left hand side or the right hand side. Most of the time you would go with whatever side that looks the longest because it's easier to simplify as opposed to expand. But in this case though, vector AP can be written, can be expanded to look. But in this question though, we'll work on the left hand side, and mainly that's because it's vector AP can be written in different ways, and that gives us more and that gives us the path to solving this question. So let's get into it. Left hand side, so I'll write left hand side right here, vector AP dot product vector AP. Right, what is that equals to? So in vectors, as you already know, you can write vectors in different variation and specifically in combinations of other vectors. So if you want to go from vector A right here into vector P, P can be anywhere, but we'll use P as this point. You can go from A to O right there and then O to P. So that's a possible option. You can go from A to O and then plus, if you add these two vectors together, O to P, you should get vector AP. And that makes sense, right? Of course, this is also vector AP, so you can write it that way. AO plus OP. Okay, right. Another way of writing vector AO, of course, is vector OA with a negative in the front. So in this case, I have negative OA plus OP. Same thing over here. Negative OA plus OP. Right. And then you can multiply, you can expand your brackets. So whenever you're expanding vectors, so when you're essentially multiplying vectors, you use the FOIL method. This is not I, J, and K, so they don't just disappear. Okay, so OA times OA, OA times OP, OP times OA, and OP times OP. You can't just go OA multiplied by OA only and OP multiplied by OP only. Okay, so that doesn't work. That only works with I, J's, and K. So your I, J, and K vectors. Right, so let's have a look. Negative OA multiplied by negative OA gives you OA times OA, of course, and then OA times OP gives us, not the positive, only the negative, OA dot OP. Same thing over here, OP dot, OA dot OP, and then OP multiplied by OP, that will give us plus OP dot OP. Right, and as you know, when a vector multiplied by its when a vector multiplied by itself, you can get its magnitude and square it. So that applies to this OP square as well. So I'll write that here. Vector OP magnitude and then square. And of course, OA, OP, they're the same. You can just add them up and you get minus 2OA dot OP. Right, and then we just, take a glance on what the right-hand side looks like. And you can already see, yes, there is a 2OA OP. That is your negative 2 OAOP. So we got that part down. We just need to get the 3R squared. So the 3R squared logically should come from these two terms right here, these two magnitude squares. So how do you get that? Okay, let's look into it. If you want to get OP, so this part right here, magnitude of OP. What is magnitude of OP? that is your radius, because that's the length, right? So that's essentially just r, and you square that, so that's our square, minus 2OA dot product OP, so that's fine. Now what about OA? OA, unfortunately, A is not on your circle, so you can't just have an R. So what does that mean? Right, if you have a look over here, you can draw a triangle. So I'll use blue. You can draw a triangle from O to this part and then up until A. So this triangle right there, this is 90 degrees. We know that this has a radius of R, so the length of R, and the length for, let's call this X. From X to A is also R, because that's the same as going from O up here. So that's R, this is 90 degrees. If you want to find the length of O to A, or the magnitude of vector OA, that is your Pythag. R square, A square plus B square under the square root, and there we go. So magnitude of OA is R square plus R square, which is 2R square, and that's under the square root. If we square that as well, what we should get is 2R square, right there. So R square plus R square, and then your square root cancels out. Of course, 2R square plus R square gives us 3R square, and there we go. It looks the exact same, so I think the textbook had this as OP, dot product OA, and that is the same as right hand side. You can just let this equals to right hand side, and then QED. So that just means you've solved it, you've showed it, okay? So that is how you solve part A, guys. Shouldn't be too much, actually really, it is actually quite hard, but hopefully this video helps you solve that problem. And then let's do part B. Hence, find AP squared plus BP squared plus CP squared plus DP squared in terms of R. Right, so what they mean by AP squared is vector AP, and then you dot product another vector AP, plus B vector BP, dot product another BP. So essentially doing all these again, but 4 times with AP, BP, CP, and DP. We know AP squared already, that is this right here. But what about BP squared, and what about CP squared, and what about DP squared? So I'll do one quickly, they're actually very similar. If you want to find what BP dot product BP is, we follow the same process here, but instead of A to O, we go B to O. B to O, dot O to P, and right here is the same, so that's your dot. B to O, dot O to P, and what you get, if you multiply this out, is of course we follow the same process. So instead of OA, you're just changing it to OB, and instead of for CP, it's just changing to OC, and for DP, that's just OD. And the end product is you end up with, so I'll just do it quickly here. You're just replacing every OA with an OB, and that's it. So for this, we should get 3R squared minus 2 OP dot OB. So essentially, you can just replace this OA with B. This would be everything that every time you see an OA, you replace it B, and you should end up with your answer. Okay, so that's what BP squared is. We do the same thing for CP squared, DP squared. You can take a shortcut really, because this is essentially the same. And what you end up with is, so I'll just write it quickly: AP squared plus BP squared plus CP squared plus DP squared is you end up with 3R squared, so 3R squared right here, minus 2OP dot OA, and then you add the same thing all over again, right? So that's AP squared, so this is AP squared, and then 3R squared minus 2OP dot OB, that is BP squared, and then of course you keep adding, so I'll just move over to the right hand side, plus 3R squared minus 2OP dot OC for your CP squared, and then of course plus 3R squared minus 2OP dot product OD for DP squared. Okay, so you can just add all your 3R squares together and you should get 12R squared because there's 4 of them. And as you can see over here, we need it in terms of R, so that's fine, right? Now, what about these OPs and OAs and OPs and OBs? What do you do with them? Okay, so if you were to ignore the bracket, it's essentially minus 2OP dot OA minus 2op dot ob minus 2op dot oc, and then minus 2op again dot od. Right, so 12r squared is still there, but what you have is you can take out, you can factorize out vector op, so 2 times vector op. You can take that out, factorize that out, and what you end up with is OA. Since we also took out the negative, everything will be plus OA plus OB plus OC plus OD. Right, so OC plus OD right there. Okay, now if you have a look back at your diagram, OA plus OB plus OC plus OD. So if you were to do that right here, so they are a square and they are the diagonals. OA plus OB plus OC plus OD. If you were to draw them in terms of vectors, what you actually get is this, a diamond. OB, and then that's OC, and then that's OD. And what it ends up is back at your original point, O, your center. So what happens in the short run is 2 times vector OP. This entire thing becomes your 0 vector because they come back to its original, to the O, to the center. And of course, anything multiplied by vector O is just 0, and you end up with the final answer as 12r squared. And that's pretty much it, because your question asks you, hence find this in terms of r. We have our answer in terms of r, and that is 12r squared. Okay, so that's pretty much it for question 21, guys. Hopefully this video helps you solve that question. I remember doing this back in school. It was actually quite difficult, but yeah, hopefully, but yes, but now you do know how to do it, and I hope you have a great day. Thanks for watching, and I'll see you in the next video.